Hello everyone, welcome back. Today we will look into the easy level problem on LeetCode called valid mountain array. We will understand the problem statement and go to the solution by step and understand the approach and then go for the solution because our focus is on improving our problem solving skills. So let's understand the problem statement first. Valid mountain array. So given an array of integers, let's say input, return true if and only if it is a valid mountain array. What does mean by valid mountain array here? So the conditions are given here. The array or the input array is mountain array if and only if the length of the array is greater than or equal to 3. See, this is a base case of this problem. They have already mentioned here that the array length should be greater than or equal to 3. And there exists some point in the array such that from the beginning the array will be increasing till that point, and from that point it will be decreasing till the end of the array. Let's understand the problem a little bit in a depth by some examples. So if you can see the input array example here, 1, 7, 8, 9, 15, 12, 10. So if you see, right, the array from the beginning is increasing. 7 is greater than 1, 8 is greater than 7, and so on. Till 15, it is increasing. And after 15, it started decreasing till the end of the array. Right? So there was only one pattern, increasing till certain point and then decreasing after that certain point. So this is a valid mountain array. You can see the mountain like structure, right? One more example, like here, from the beginning, it was increasing. Well, 12 is greater than 1, but from the point 12, it started decreasing, right? Till the end of the array. So first it started strictly increasing and later it started strictly decreasing, right? These are the examples of valid mountain array, right? Now let's understand some of the examples which are not a valid mountain array. For example, this array, right? If you see, this is a already descending order. The array is in descending order, right? So if you look at the line, it is just decreasing. So for array to be valid mountain array, it should be increasing first and then decreasing from one point till the end of the array. So this is not a valid mountain array. Similarly, this one more example where the array is completely increasing till the end of the array from beginning to end. So again, this is not a valid mountain array. There will be some array where it will start increasing, then decreasing, then again increasing, then again decreasing. So if you see here, the pattern is like increasing, decreasing, then again increasing. So, but for a array to be valid mountain array, it should be increasing and then decreasing. There should not be the fluctuation, right? So this is also not a valid mountain array. So let's understand let's go into the solution. So if you see this array, which was a valid mountain array, right? It was strictly increasing till the point 15, and then it started decreasing from 15 till the end of the array, right? So if you see from end, right? From end, if you see 10 from 10, even though in a valid mountain array, we'll see it is decreasing from 15 to 10. But if you see from end to 15, it is actually strictly increasing, right? If you check from that. Now, if you see that if we start from the beginning and if we start from the end and just check for the strictly increasing, then we should reach to one common point to say that it is a valid mountain array. The common point or the valid common point from beginning and end is a 15 here, right? So using this, we will use a two index method, right? We will have a left and right. Left we will initialize at the beginning of the array. Right we will initialize at the end of the array. So now what we need to do is we need to increment left from beginning till it reaches to the left, and it is a strictly increasing. So 7 is greater than 1, so incremented left, keep incrementing till 15, because it will keep incrementing till it is strictly increasing, right? Now similarly from the end, decrement the right if it is a strictly increasing, right? If you see 10, 12, 15, it is strictly increasing, right? Now, if you see that left and right meet at one point. So if left and right are pointing to the same position, and left is not at the start of the array and right is not at the end of the array, then it is a valid mountain array. Why left should not point to the start of the array? So if you see this example, right, this is just strictly increasing, right? So here both left and right will meet at the end, because left will start from 1 and strictly increasing it will go until 4. From right we cannot move because from end 3 is not greater than 4. So right will be at the end only. So in this case, if you see, left and right are meeting, but they are meeting at the end of the array. So this is not a valid mountain array. It is just increasing. Similarly, in case of just decreasing array, left and right will meet here. So which is again just decreasing. We had seen one of the example where just decreasing array is also not a valid mountain array, because we need to have increasing first, and from certain point it should be decreasing till the end of the array. So this will be our logic. Now let's go to the solution. So what we need to do, we will declare two variables as discussed in a solution: left, which will start from the beginning of the array, and right, which will start from the end of the array. If length of the array is less than 3, then return false. This is a base case, right? For every problem we have, there will be some base case where you can directly return the output. Now we will increment the left pointer till we reach the right, and the sequence is increasing, like the current left is less than the next element, so left plus plus. After that we will decrement the right till the left is less than right, and the right is from the end we are going in an increasing manner, so we will decrement the right index. So now if any of this true, it means that if left and right are not matching, it means that there is no common point. Left is pointing at some other index and right is pointing at some other index, then it is not meeting at a common index. For a mountain to be formed, if you start from beginning and if you start from end, it should reach to some common point right here. So left and right should point. If it is not pointing, or left is pointing at 0, which is for this just a decreasing array, or right is pointing at the end, which is just for increasing array. If any of this true, then return false, means it is not a valid mountain array. So I already ran some of the base cases given here. I'll just submit. Great. So what is the time complexity of this solution, right? So in this case, we are just parsing till the end length of the array. So input, it runtime complexity depends on the input size, right? So here input size is basically nothing but the array length, right? So for example, let's say if we consider that array length as n, then we are in a worst case we are parsing the whole array once. So it is just O of n. So the complexity, the time complexity of this solution is O of n. So which is the best? So this is the optimal solution for this problem. If you like the explanation and solution, please subscribe and share. Thank you.